take a look at calorimetry. This is going to be a technique that's used to measure the heat that's transferred from one substance to another. And we can use what's called a calorimeter in order to do that. So, of course, in real industry, there are some very, very fancy calorimeters out there. We're not going to necessarily be worrying about the fancy ones in this course, but we are going to have an opportunity to make our own calorimeter in class. Now, on this left side of your screen, you'll see a legit calorimeter that's like that you would use in industry. Okay. We, however, we're going to use this more primitive form, which is where you're basically going to have a container. Okay. And inside the container, you can put like a little cork or something like that, a little toothpick with some sort of food or something like that, something that you're going to burn attached to it, okay, just like we have right here. Um, you're then going to take another container, which you can put like um, some sort of a something through, like a well, that's not going to work, but either way, you can put some sort of pin through it, and when you do, you can set it nicely inside the other thing. So when you light whatever you're going to light on fire, you can set your other container on top. Okay. Now what this is going to have, your other container, think of it as like a coffee can and a soda can. Okay. And then the soda can is going to have water in it, and you're going to have your food piece down here. Now, when you light the food on fire, some energy is going to be transferred from the food to the water. Now, in this course, we're going to assume that all of the heat is being transferred solely to the water. Now, if we think about that, obviously we understand that some of the heat is going to be lost in the surroundings, some of the heat is going to be lost to the metal in the can, so on and so forth. But for this course, we're going to assume that all of the heat is transferred to the water. So what's going to happen is this is also going to lose some amount of mass, and so you can find out exactly the mass that was burned, and you can find the change in temperature. And then when you do, you can use that information in our MCAT formula. So let's go ahead and take a look at a problem. So this problem tells us that we have a 0.303 gram sample of sugar that's burned in a calorimeter containing 240 grams of water. During the process, the temperature of the water changed from this to that. What was the heat change of the sugar? Well, when we're doing this, we need to focus on the water first. If we focus on the water first, we can then come back to the sugar at the end of the problem, okay? So let's go ahead and do an MCAT formula, which of course is delta H equals MC delta T. We're going to solve for the heat change of the water to begin with. So we're going to do delta H equals our mass of water that we have is 240 grams. The specific heat of water, which is given to us, is 4.184. And our delta T, our change in temperature, is our final temperature of 27.55 minus our initial temperature of 22.53. So this is going to tell us how much energy was absorbed by the water. And when we do this calculation, we find out that 5,040 joules of energy is actually absorbed by the H2O. Okay? Now that energy had to come from somewhere, right? That's where our sugar comes into play. Now remember, for our calorimeter, we're going to assume that every bit of the energy absorbed by the water came from the sugar. Okay? And so what that tells us is that 5,040 joules was absorbed by H2O, we would say that the delta H of the sugar would be negative 5,040 joules. So that tells us 5,040 joules of heat was given off from the sugar and was absorbed by the water. Okay, so this says to gain some perspective, let's convert this into food calories. Okay, and so according to our conversion factors here, we know that 5,040 joules is what we're starting with. Okay, and we can convert joules to calories by using this formula right here, this conversion factor. Okay, so I'm going to go from joules to calories, and I know that 1 calorie is worth 4.184 joules. Now, this isn't the calorie that we consider to be a food calorie. A food calorie is actually what we would call a kcal or a kilocalorie. And so if it's a kilocalorie, we can go from cals to kcals or food cals, whatever you want to call them, by saying that 1 kcal or one food calorie is 1,000 calories. Okay, and so now I can just plug all this into my formula, and I get a final answer of 1.20 kcals. Oops, kcal, or 1.20 food calories, whichever one you want to call it is acceptable. Okay, so that gets us some information there. We're going to go ahead and take a look at number 3. And number 3 wants us to find the heat of combustion, which is given to us in kilojoules per mole. So basically what I need to do here is I need to say, okay, if I'm starting off with 0.303 grams of sugar, I need to find how many moles that is. So what I'm going to do is I'm going to take 0.303 grams, and I'm going to divide that by the molar mass of sucrose, which just happens to be 342.22. 342.22. And so when I do this math, I figure out that I have 8.85 times 10 to the negative 4th moles of sugar. So now that gets us the mole portion of our kilojoules per mole. Well, remember the amount of energy, or the amount of kilojoules that was given off, we said that was negative 5,040 joules. Well, take a look at what it's asking for. It's asking for kilojoules. So I need to convert joules to kilojoules. So when I do that, I'm going to get negative 5.040 kilojoules. To do kilojoules over moles, I'm just going to divide that number by the moles that we calculated earlier, which was 8.85 times 10 to the negative 4th moles. So now I have kilojoules over moles. So now I just need to do this math. And when I do, I get my answer is negative 5.70 times 10 to the 3rd kilojoules per mole. And so that's how we're going to solve that kind of equation. Lastly, it says, for the above combustion of sugar, would heat be listed as a reactant or a product? And it wants you to explain your thoughts. Well, remember, the delta H that we got for sugar was negative. Okay, remember, you had 5,040 joules of heat that was absorbed by the water, but that 5,040 joules came from being released from the sugar. So since the delta H was negative, since heat was released, we would say that heat was a product, and so we would put that 5.040 kilojoules, or that 5,040 joules, on the product's side of the equation.